Hello students. So today's session is on the revision part 2. Like already we have discussed about the ICSE class 9 revision for part 1, right? So I have seen that lots of students gone through my session, and I hope that will be useful for you. Okay. So today I am going to take the next set of revision classes. Okay. So already we have discussed about the motion, vertical motion, linear motion, then the force. Okay, I hope you are ready. So in a nutshell, what we discussed earlier, like vertical motion or normal v is equal to plus 80. In vertical motion, it will be v is equal to u plus gt, right? This is for downward, and upward v is equal to u minus gt. I hope you are ready with these things. Like if I am applying, if I am throwing a ball with velocity u, what will be the height, maximum height reached by the object? If the height is h, then equation will be v square is equal to u square minus 2gh, right? So here final velocity is 0, final velocity is 0. So from here h will be is equal to u square by 2g. So this will get the maximum height when you are throwing it. So max height depends on the initial velocity and the g. G is the acceleration due to gravity, right? I hope these things are already clear to you. Next was the Newton's force of equation. We discussed that force is proportional to rate of change of momentum by t, right? From here we have received this force is equal to mv minus mv by t, or you can write ft is equal to mv minus mu. That means change in momentum means force into time. So if you have force and time, you will get the change in momentum. If you have the final velocity, initial velocity, and mass, you will get the impulse. So force into time is called impulse. So sometimes you get a question like, what is the impulse? So force into time is the impulse, right? Now, so this is for Newton's second law, and next is that recoiling part already we have discussed. Now today I will be focusing on the pressure. So for pressure, the very basic things we have that, let's say this is in water. So this water is in a container having height h and the area is a. Okay, so volume of the container V will be equal to HA. Now, if the density of the water is rho, then mass of the water for this container is m is equal to v rho. Mass is equal to v rho, right? Or I can write m is equal to v means h a rho. So this is the expression of mass for this liquid water. Now, the for this mass, the downward weight, right? W is equal to mg. Downward weight W is equal to mg. Now, let's take an example of this part here for this bottle, right? So if I am taking this bottle like this, so what is happening here? That this bottle, this part of this water, so this part will having a weight, and this will exert a force in my hand. This will exert a force in my hand, right? For this one. So here similarly, this liquid exert a force in this area. So the force or thrust here, the force acting perpendicular direction in this area. That is the weight is equal to mg, acting vertically downward. So pressure, the standard formula pressure is equal to P is equal to F by A, right? P is equal to, during the pressure chapter, when we are calculating pressure for a solid material, we discussed that pressure is equal to force by area. Same formula will be applied here. Pressure is equal to force by area. But here force means what? Here force F is equal to mg. Force is equal to mg. So pressure P will be is equal to here mg by A, and m for H a rho, H a rho G by A. So P is equal to H rho G, right? So this is the expression for the liquid pressure. So liquid pressure in a container depend on the density of the liquid, acceleration due to gravity, and the height of the liquid. Now with this same area, if I increase the height of the liquid, my pressure will be increasing. So more the height, the pressure will be increasing here. This is called liquid column. This word is very important. Now, now let's go to the application part. Whenever we are in a deep sea, right? So, or in a water lake, what happened that this is the surface level. So, let's say these are different inner levels. So, if this is the surface of water, here pressure is P1, here pressure is P2. So what happens? P1 is equal to H1 rho G. H1 is the height from the surface. This is H1 and this is H2 height from the surface. So here H2 greater than H1. That means P2 is greater than P1. That means more the height from the surface, more deeper you are going, the more pressure you will be receiving. Same happening with the submarine. So submarine when it is going down inside the water, the more vertical height it is going, more pressure it will receive. Same happen for the sea fish or sea animals, right? So they are always staying in under pressure. They are adapted like that. So whenever they are coming out, so there is a problem because in the surface the pressure is low. So it's against their survival, right? So this is about the liquid pressure. Now next is the upthrust, right? And before that there is a Pascal law. In the pressure chapter, lots of the numeric, most numeric will be from here, like F1 by A1 is equal to F2 by A2. Almost the numeric will be, will be moving like this. From where it is coming? If we go in the Pascal law, right? It is coming from the Pascal law. So let's say this is the piston, we are giving a force, and this is the liquid container. This is a closed container in liquid. So let's say this area is A1, we are applying a force F1 here, and this area is A2, and we are receiving a force, upward force F2 here. So what happened whenever F1 is applied in this through piston to the area A1? So the pressure acting here is, P1 is equal to F1 by A1. Now the same pressure according to the Pascal law, the same pressure will flow inside the this closed container, right? So here it will hit the same pressure, that is P1. The same pressure will flow, will transmit inside the water in undiminished way, the same magnitude, and this will hit here as a P1. Now so here I can say P1 is equal to P2. So P2 means the F2 by A2. The F2 we are receiving here, right? So, and P1 we discuss about F1 by A1. So, from Pascal law we are getting this F1 by A1 is equal to F2 by A2. Now, this one we can write like, F2 is equal to A2 by A1 into F1. Now, if A2 is greater than A1, then your F2 will be greater than F1. So, force getting multiplied. Same happen in the hydraulic machines, right? You are applying a low force, you are getting a high amount of output here. The mechanical advantage you are getting, right? So this is due to the Pascal law. So this is one of the application, and most of the numerics in pressure is coming from this part, right? Okay. Now next is the upthrust. So upthrust part is now what we will be receiving there. Like if this is a liquid here, this is the liquid. You have some object here. Okay. So this what happened to force. The liquid is giving an upward force, the upward pressure on this object, and this object will be giving a downward, force, that is weight is equal to mg. Whenever we are taking an object inside the liquid, this will give a downward pressure, downward force. Weight is equal to mg. The weight of this object, right? Weight of this object will act downward like this weight. Now, inside the liquid, there is an upward pressure, and that caused, and this was discovered by Archimedes, that there is an upthrust force experienced by these objects whenever it is fully or partially merged in a liquid, it will receive an upward force that called upthrust. So this is an inbuilt. The upthrust is coming from the fluid itself. This upthrust is coming both in liquid and also in the air medium, right? Same happening for parachute, right? Whenever a parachute is coming, you'll be receiving, some kind of upward force from the air media. So this upthrust force valid for both liquid and the air media, right? So now we are discussing about the liquid. In this liquid will give an upward force to this object that called FB, force of buoyancy. Force of buoyancy. This FB, whenever the object will be float, this FB will be greater than equal to the weight of the object. So this is the condition of floating. So this is the condition of floating, that weight of the object will be greater than the downward weight. When upthrust will be greater than the downward weight. So FB is equal to V rho G. So V is the volume of the displaced liquid. The liquid displaced by this object, this volume. The liquid displaced by the object. This is this volume of the displaced liquid or water, and density. This density is the density of this liquid. This liquid. Okay. So more density liquid means that the upthrust force will be higher. So this rho is the density of this liquid. Okay. So this FB. So in the numerical, we will be receiving FB is equal to W, right? That means V rho G will be mg. From here, you will get lots of numerical. Okay. Follow my classes in next class. I will continue from here. Okay. Just continue my session, and any questions, please let me know. Thank you.